Hi, in this video I am going to discuss integration of rational function. Rational function are what? These are of the form px by qx, where px and qx are polynomial. So let's start. You already know what is a polynomial. Px is said to be a polynomial if it is of the form such that a px is equal to a0, let's let an xn plus an minus 1 xn minus 1 till a1 x a0. So some example would be, let's say, 4x cube plus 3x square plus 9x plus 2. This is a polynomial, and you can take different example too, like x cube plus x. This is also a polynomial. Here the a2, which is the coefficient of x square, is 0, and also a0 is also 0, but a3 is equal to 1 and a1 is equal to 1. Okay, but this, which means x to the power half, this is not a polynomial. Here the n, whatever is appearing, this should be natural number, or it can also be 0. So but here this is a not a natural number, right? Half. So this n just belongs to I have already written down natural number or 0. So these are polynomial, and an minus 1 till a0, this belongs to rational, or sorry, real numbers. Okay, so this is the symbol for real numbers. So this is the definition of polynomial. So when we do integration of polynomial by a polynomial, that is rational function, we first need to check what is the degree of px. So what is the meaning of degree of a polynomial? This is the highest power of x that is appearing in px. Okay, so you see this here in px, the highest power appearing, let's, in this case is 3, in this case also 3. So suppose, let's say, this is our polynomial, then the highest power of x is 2. Similarly, you can also write minus 4x plus 1. Here the, sorry, here the power is 1, highest power is 1, so degree is 1. So first you need to check that if degree px is greater than equal to degree of qx, yes or no. You have to check it. If degree of px is greater than equal to degree of qx, you divide it. How do you divide it? Let's say px is something x square plus 2x plus 1, and qx is x plus 1. Okay, So how do you divide it? X square plus 2x plus 1, and then qx is x plus 1. So if you want to cancel out x square, so if you take here x, then this will be x into x will be x square plus 1 into x will be x. So this is, then if you subtract it, x square minus x square, this will be 0, and then 2x minus x will be x plus 1 minus 0, so it will be 1 again. Now if you take plus 1, x into 1 will be x, 1 into 1 will be 1, then you subtract it again, you will get 0. So now you can write x square plus 2x plus 1 to be what? X plus 1 into x plus 1 plus 0. 0 is the remainder. So we have to write px as whatever is qx, then you will get a polynomial here. Let's denote it by gx plus rx, which is the remainder. So now degree rx is less than, should be less than degree qx. Okay, so this is how you factorize a polynomial. Let's take another example. Maybe let's say x cube x square plus x. Okay, then I want to divide it by, let's say, x cube. In this case, you will take 1, let's say, then you will be x cube, subtract it, you will get 0. Okay, so this will be x square plus x. So in this case, px is x cube plus x square plus x is equal to x cube into 1 plus remainder is x square plus x. So rx is our x square plus x, and degree of rx is what? 2, which is less than degree of qx, which is equal to 3. Okay, so if your degree px is greater than equal to degree qx, you factorize it using this division, and uh, not factorize it, I mean divide it by qx, so that you will get a remainder term. Okay, so in this question, the first question here, where it is, this question, we have already given this numerator is 1, so this degree is less than obviously this factor, because here there is x to the power 1. Okay, and it is also multiplied with x square plus 1 square. Okay, so we don't need to divide the polynomial, so we'll just take it as it is. And now what we will do is, so the method is, suppose this is px by qx, first factorize, first make it into the form of something uh, such that degree of px is less than degree of qx. How will you do that? you, if it is greater than equal to qx, degree of px is greater than equal to degree of qx, you divide it, okay, and then write px as what, qx into some polynomial. I think I have written gx plus rx, okay. So what will you do now? You divide it by, if you divide it by qx, you will get, this will be gx plus rx by qx. Now rx follows, I mean rx has degree less than qx. Okay, this is a theorem, you don't need to know the theorem, you just need to remember that if you divide it, the remainder always has degree less than qx. So if you integrate this thing, you will get integration of this and this, okay. Okay, so in our case we don't need it because we are given this thing, okay. And so before going into solving this, how we use the partial fraction method of integration is that, suppose qx is given here, first you have to make sure that px has less degree than qx, then after that factorize qx into linear factors. Let's say this, then x minus b, let's say, and 2 x square plus some cx plus d and 3. Suppose our qx is like this, okay. So for example, let's say let our qx be x square plus 2x, then you can write it as x into x plus 2, right? So you need to factorize it. Suppose our qx is x square minus 4, then you will write it as x square x minus 2 x plus 2. So after dividing px by qx, if your degree px is greater than equal to degree qx, you have to divide it and then you will get a remainder term, and you can write it like this, okay. Then rx has degree less than qx. Now you can use the partial fraction method. How to use it, I have already explained you step 1. Then the step 2 is you factorize qx into linear and quadratic factors, okay. So I have given some example here, right, how to factorize qx into linear. This is x minus 0, then x minus of minus 2. So this is factorized into 2 linear factor. Here also it is factorized into 4 linear factors, where x minus 0, which is x, is appearing 2 times, okay. So you have to factorize qx into linear and quadratic factors, and for each linear factor you have to associate one a. You have to write it like this. If your x minus a is appearing in factorization of qx, you have to write it, suppose it is appearing n times, so you have to write this as equal to this, okay. 9, total 9 times you have to, not 9 times, n times, okay. So if it has quadratic factor which cannot be further, I mean factorized into linear factor, and this appears in your factorization m times, so you have to associate b1 x plus c1 m times, okay, like this. So let me illustrate it using our assignment problem. So where yeah, so let's start. So in this question you can see um our polynomial is 1 by this thing. So degree of this 1 is, you can think of it as x to the power 0. So this has degree 0, and in denominator we have degree 1, and then 2x, x to the power 2, so this will be 2. This is twice, so 4 plus 1, degree is 5. So below we have 5-degree polynomial, so we don't need to divide it because already this degree of px is less than degree of qx. Now the second step is to, I mean, factorize it. It is already factorized. X is appearing one time and x square plus 1 is appearing two times. So this is our linear factor, this is our quadratic factor. You cannot further factorize x square plus 1 because obviously no, if you see the discriminant it is -4, so it will have complex roots. So we are dealing in real number, we won't go there. So this we have factorized. Now just as I told you, we have to associate for linear factor, we have to associate one uh, a. Okay, so I am writing it as a by x. Okay, and now the highest power is 1, so we only need to do it once. For x square plus 1, the power is, I mean, it is to the power 2, right? So what will we do? b1x plus c1, because this is a quadratic factor, we are taking b1x plus c1. Then because this is power is 2, we have to again do it, x square plus 1 square, this is b2x plus c2, then we equate it. Okay, so let me, yeah, so that's what I meant when I say a1 by x. Here in that case only x minus a, which is a is 0 x, because there we had x, right? So and the power is 1 only, so only once a will appear. And for x square plus 1, here p was 0 and q was 1 and m was 2, so we have to take 2, b1x plus c1 and b2x plus c2, and here to the power 1 to the power 2, so 2. If m to the power m appears, a quadratic factor to the power m appears, then you should take it, this thing should be m times. There we had 2 times, so I took b1x plus c1 and b2x plus c2. Now equate it. After equating, okay, so now you multiply the numerator, okay, sorry, denominator, and then you will get this equation. I'm leaving you the calculation, you check if I am doing correctly, and if it is wrong you let me know, or you can do it on your own. Just check the calculation, this will come out. Then you collect the power of x to the power 4, collect the power of x to the power 3, 2, 1, everything you collect it like this: a plus b1 x to the power 4, then x cube, then x square, then x, then the x to the power 0, okay, so a constant. Okay, so now what will you do? You equate this to this side. So what you will get, there is no x to the power 4 here, right? So a plus b1 must be 0, and then there is no x cube term here, so take c1 to be 0, and then x square coefficient also must vanish because there is no x square here. So this is also 0, and c1 plus c2 will also be 0 by same logic, and the a must be 1 because there is 1 here. Okay, so now if you solve this, since c1 is equal to 0, then c1 plus c2 is equal to 0, c1 is equal to 0, so c2 is equal to 0, and also a is equal to 1, that we have already seen. So b1 will be is equal to minus a, which will be minus 1. So b1 we also found out. Then if you put a is equal to 1 here, b is equal to -1 here, then you will find b2, which will be -1. So you have found a1, b1, b2, c2. So I have made a typo here. uh, I think I am saying a1. I don't uh, I mean a. Okay, a1, a, whatever you want to call it. So now we have found out what is a, b1, c1, b2, c2. So if you put this value, you will get a by x. Then yeah, so b1 is -1, so it will be minus x plus c1 is 0, so minus x dx. And here b2x plus c2, you can check it. b2 is -1, so minus. Oh, I think I have missed something. b2 is b2 is -1. Okay, let me correct it. So b2x plus c2 will be, this is minus x plus c2 is 0, so this must be minus x. Okay, so I think I have made error here. So anyway, I'm telling you how to do it. So 1 by x dx, this you can integrate ln x. Okay, and then if you do this one here, you have to use substitution. If you take what, let me see, if you take t is equal to x square, then I'm first dividing by 2 and multiplying by 2, so this will be 2x by x square plus 1. You will, if you take t as x square and use the substitution theorem for integration, you will get dt by t plus 1. So now you can see this will be ln, I have to write ln, sorry for the mistake. Yeah, this will reduce to ln 1 plus x square, and now I mean ln 1 plus t, and t is x square, so ln 1 plus x square. And I think I have made mistakes here, so I'm going to erase this thing. So this, for this thing, yeah, this is minus x, right? This thing I have to erase. This will be minus x dx by x square plus 1 whole square. X dx x square plus 1 whole square. Okay, so can you integrate this? Okay, so you divide by 2 and multiply by 2, and then take t is equal to x square, so you will get t plus 1 square, and then 2x dx is equal to dt, so you will get dt here and you will get 1 by 2 here. And then if you integrate this, you will get t plus 1 minus 2 plus 1 minus 2 plus 1 half. Okay, and so this will reduce to ln mod x plus minus 1 by 2. This is ln 1 plus t, which will be 1 plus x square, and then minus of half this thing. Minus 2 plus 1 will be -1, and then 1 t plus 1, right? And this minus it will become plus, so this will be ln mod x minus half ln 1 plus x square. This will get plus half t plus 1, and t plus 1 is t is our x square, so this will be x square plus 1. Okay, so this solves the question number this solves the question number 2 3a. So yeah, so this thing I have written wrong.